Well, good morning. It's Tuesday. When I started making this, I put Monday because we didn't have school yesterday and it felt like Monday. But it's Tuesday, 5/26/20. Getting to the end of May. It's amazing. Today, we're going to look primarily at distillation. It's going to be a pretty short one. I can explain how distillation is used to purify water. Just a quick review. Last class, we talked about filtration. So filtration separates materials by the size of the particles. So the smaller the holes in whatever screen, the smaller the stuff that passes through and the bigger stuff stays out. So if you've got big holes, it can only take out big stuff. A little bit smaller holes takes out some of this. And the smallest things keep going through. So thinking about that, we said we had three main types of contaminants, okay? Particles, biologicals, chemicals, okay? So particles, if I've got actual muddy water, I want you to think about how does filtration, when we pass it through something with little holes, how well does that work for each of those? So think about particles. Does filtration work pretty good for taking out particles? I'll let you think. The answer is yes. Filtration works quite well for filtering particles out. Okay, those particles tend to be a lot larger than the water molecules that we're dealing with. That's pretty good. Biologicals. We're talking about bacteria, parasites, amoebas, viruses. How does filtration work? You maybe don't know. I want you to make a guess. Think about it. The answer is most filters won't hardly touch those. Okay, maybe some of the bigger bacteria. There are some pretty specialized filters out there. And yet, if you just think about pouring something through like a coffee filter, no. Biologicals, bacteria, and viruses go right through that. You would need a real super filter that would probably have to be under high pressure. Your reverse osmosis systems really are kind of like a high pressure filtration. And they might touch some of that, okay? But typical filtration is not going to do a good job of getting rid of biologicals. So if you're going camping and you got a muddy stream and you just take out a coffee filter and put some of that water through the coffee filter, that's not safe to drink. Okay, chemicals. What if you got salts? What if you've got lead in the water? What if you got mercury in the water? Fertilizers. If you've got chemicals in your water supply, do you think filtration will take those out? Think about it. The answer is largely no. Okay, those individual compounds are probably even smaller than these biologicals, and so typical filtration won't touch those. Okay, again, there may be some really high-tech specialized things out there, but typical filtration isn't going to remove those. So filtration gets rid of particles, but not much of the other stuff. So if I want to clean my water, I got to do something else. So here's where we're going to get into distillation. Okay? I say distillation is a separation of mixture based on differences in boiling point. Boiling point is the temperature at which something boils at ordinary pressure. Okay? It turns from liquid to gas. And then as I'm thinking about it, really sometimes we can broaden that definition of distillation. If we are vaporizing one material but not other materials, it's really a type of distillation. It wouldn't necessarily always have to get to boiling. It could involve evaporation. So in a broader sense, we're vaporizing some substances but not others. Let's take a look at it closer. Right. Here here's a laboratory style distillation apparatus, okay? So imagine I make up some polluted water. I got some raw sewage, okay? I don't want to drink that. Okay, raw sewage, one, there's going to be particles in there. There's going to be biological factors in there. There could be chemicals in there. I certainly don't want to drink that. So if I put that polluted water in this flask and heat it up, eventually some of that is going to boil. The water is going to boil. Now, different substances change to a vapor at different temperatures. Or even if we're not boiling it all the way, some substances turn to a vapor easier than others. Okay? So the water in here turns to a vapor easier than, say, the chemical compounds in urine. So the water turns to a vapor. Now, the vapor comes up, this is stoppered, so it can't go that way, so the vapor gets pushed through this tube. And this tube is surrounded by a second tube full of cold water. So that causes the water vapor to condense and drip out here. Now, the substances that didn't turn to a vapor stay there and get more and more concentrated. The water comes across. And when done correctly, this can lead to very, very pure water. So whatever we're trying to remove has a different boiling point than the impurities. Now, this can actually be used to separate some mixtures that are very difficult. Let's say alcohol and water. Alcohol and water dissolve in each other in any proportion. And that's a very challenging mixture to separate. But alcohol has a lower boiling point than water. So if you had a mixture of alcohol and water and you start heating this up, as it warms up, the first stuff that turns to a vapor is going to tend to be alcohol. So the first drops that come out here will tend to be the alcohol. Now, if you keep heating it, eventually the water is going to come too, right? So the trick would be to heat it up slowly, capture the first stuff that comes across, okay, and then take that away before the water starts to come. Now, there's probably going to be a little bit of water that comes through, so if you repeat it again, and you capture the first stuff that comes across, and then take that and do it again and capture. Eventually, after doing several distillation steps, you can even get a good separation of things as well mixed as alcohol and water. Now, something like my raw sewage that I was talking about probably separates much, much easier than that. Okay? How about just salt water? If I had salt water, salt would require a few thousand degrees to boil, whereas water boils at 100 degrees Celsius. That's quite a drastic difference. So if we boil that, the water comes across, the salt stays behind. Okay. Now you can get into problems if you boil this really vigorously, stuff splashes around in here, and so sometimes in my lab setups, if I do this too fast, I don't get the best separation. But if we do it carefully, we can get very good separation. Let's think about our different contaminants. Particles. Is distillation, is distillation going to work to remove particles? Think about it. The answer is yes. The particles, they're not going to boil at the same temperature as water. They're going to tend to stay in our original flask. Biologicals, bacteria, parasites, viruses. Well, the thing that you got to think about here is if you heat this up, if you're doing a distillation where you're boiling the water, the biologicals are going to get killed in that process. Okay? If you do a slow distillation where something's just evaporating, the biologicals are likely going to be left behind with the particles. So distillation is pretty good at separating out biologicals. Chemicals, think about it. Distillation is pretty good at removing chemicals, especially if you do multiple distillations. So distillation can work for all of these. Now, distillation is also much more energy intensive. So you can see that our first step in water purification usually is to use filtration and get out the particles. Okay? And then a lot of times, instead of doing a distillation, to get rid of biologicals, we might just do a chemical treatment where, say, we add some chlorine or something like that, chlorine or ozone to the water to kill any biologicals that are in it. Then it sounds like we're actually adding chemical contamination. So for a water treatment system, what you'd need is, like, you add the chlorine in just a high enough dose to kill that, but not in a high enough dose to kill the people that are drinking it. Plus, chlorine over time will tend to leach out of the water, and so it gets reduced as you go on. If you live close to the water treatment plant, you might have more chlorine in your water than if you live further away from it. Also, in this sense, in this water treatment plant, we're hoping to start out with a sample of water that doesn't have this type of contamination. Okay, so if we were going to purify water from the river for drinking, and a lot of places do that, we're going to take water out of the river. We know that there's particles in the river. We want to filter that out. We know there's biologicals in the river. We can maybe treat that chemically. We hope that our river is clean of chemical contamination, and so we're going to put it through testing to see that. And if we start getting tests for certain chemicals, then we may have to put other specific treatment plans in to get rid of those. So here's something called a solar still. And I remember this from when I took a hunter safety class all those years ago. If you're lost in the wilderness, and of course you got your emergency pack with you, and you've got a piece of plastic in there, maybe it's a rain poncho or something. You got a little container, you got a little bit of tubing, you dig a hole. Maybe you put some extra vegetation down in the hole. You put your container in the bottom of the hole. You put your tube in your container and run it to the top. You take your sheet of plastic and you put it over the hole and you weight it down with rocks all around the outside. And then you put a small rock in the middle to make this depression. And what happens is when the sun shines in here, it evaporates water out of the soil and out of this whatever you put in here, foliage, sewage. Don't really recommend that. But the water evaporates, it comes up, now it hits this barrier. It's in the way, it can't get out. And so what tends to happen is that water condenses on that sheet of plastic, and because the plastic goes downhill, the water runs downhill, drips into this cup. And supposedly, if you had a decent sized area, you can maybe get a liter of water a day out of something like that. Your body needs a few liters a day. So it is a distillation process, because while it's not boiling anything, you're changing the water to a vapor and then back to a liquid. Then I want you to think about the water cycle. How does the song go? Mr. Brzezinski has it. Evaporation, condensation, precipitation on my head, something like that. Well, the sun shines on all this water out here, you get evaporation. The water's turning into a vapor. Gets to the upper atmosphere, it's cold up there, it condenses and falls back down. The stuff that's falling down is really very clean. The water cycle is a giant distillation process. We are distilling water on our planet all the time. And this is something, this is rather clean water. The problem is it doesn't fall everywhere equally, and it doesn't always fall in the amounts we want. And there's parts of the world that are going through droughts, and then there's parts of the world that get too much of this all at once, and then it's running across the ground and creating all sorts of other problems with contamination. So the water cycle is a natural purification process. It is a form of distillation. large scale distillation. Now just a note, rain is not entirely pure because you could have contaminants in your atmosphere that get absorbed. So if you have a place with a lot of pollution in the atmosphere, some of that pollution is going to be in the rain as it comes down. But overall, rain is pure, pretty pure. And yeah, that's as far as I wanted to go here today. Get you a couple questions.